Hello and welcome to today's lesson on the binomial distribution. Today we'll be specifically looking at the mean, variance, and standard deviation for the binomial. So let's begin. If you'll recall first that for any discrete probability distribution, we were able to find the mean, mu. That's mu right there, lowercase mu. Mu equals the sum, remember this capital sigma means sum, the sum over x times the probability of x. So you sum that up for all x. And then the variance is this sigma squared, lowercase sigma squared. The variance, and we're going to use the shortcut formula, we're going to sum up over all x squared times the probability of x, and then take that sum and subtract the square of your mean. That's our variance. Now for the binomial distribution, since we're dealing with a specific distribution, we can actually get to the mean and variance and standard deviation in a lot quicker fashion. For the mean, what you're going to do is take n is your number of trials, times p. P is the probability of success. If you just take the number of trials times the probability of success, that will give you your mean for our binomial distribution. Now, for your variance, sigma squared, you take n times p times q, where q is the probability of failure. Which then leads to your standard deviation, which is just simply the square root of your variance. So for your standard deviation for a binomial, you'll take the square root of n times p times q. So let's look at an example. If you'll remember, we talked about this number of girls problem before. So if we wanted to find the mean and standard deviation for the number of girls in a group of 14 births, before that would take us quite a while. Well, now we know that this is a binomial experiment. We have a set number of trials, 14 trials. The probability of success is constant. Probability of a girl, 0.5. And we're also going to assume independence amongst the trials. So each birth is independent of what has previously happened. So let's use the binomial distribution formulas to find the mean. So you'll see for the mean, mu, I take n times p, and I have 14 times 0.5, which is 7. Now for the standard deviation, sigma, I'm going to take the square root of n times p times q. So n times p is already 7 times 0.5. Half of 7 is 3.5. So it will give me the square root of 3.5, which I don't know off the top of my head. Oh, it's 1.9, rounded. So what does that really tell me? So if we were to have 14 births, the expected number of girls would be 7. That makes sense. You have a 50-50 chance. You have 14 girls, 14 births, 7 of them will be girls. The standard deviation is 1.9. Loosely, you can interpret that as any given scenario will deviate from the mean 1.9 girls. So you pick a family of 14 children randomly. The average distance the number of girls away is from 7 is 1.9. That's kind of a loose interpretation there. Remember also we talked about usual values. We said typically values deviate from the mean by 2 standard deviations. So the usual max is mu plus 2 sigma. So mu plus 2 standard deviations is the usual maximum, and the usual minimum is mu minus 2 standard deviations. So if I wanted to find the usual maximum number of girls, I could do that. So let's look at an example. Say you had 100 babies. 100 babies being born, and 68 of them were girls. And you might think, that seems unusually large. Well, let's investigate. Well, we could find the mean. Once again, we could find the mean. I know it's over here on the left, but we'll do it anyway. N is 100. P is 0.5. We'll get a mean of 50. Well, standard deviation, square root of N times P times Q, which in this case, 100 times 0.5 is 50, times 0.5 again is 25. So my variance is 25, but we wanted the standard deviation. Square root of 25 is 5. So that's where we got these two values over here. Mu, 50, standard deviation, 5. So now you want to find the usual max. Well, we're going to add 2 standard deviations above, and that will be our usual max. So we'll take our mean, 50, plus 2 times our standard deviation, which is 5. 50 plus 10 gives us 60. And then for the minimum, we're going to go 2 standard deviations below. So you'll do mean minus 2 standard deviations. 50 minus 10 gets you 40. So what does that really mean? We would consider anything between 40 girls and 60 girls to be usual values. So if you thought 68 girls among 100 babies was unusual, you were right, because this is outside of our usual range. So we would interpret that as 68 girls and 100 births is an unusual result. I hope you took good notes. Be prepared to answer some questions when we come back.